Dear students, last time we studied about the RC coupled amplifier, its frequency response, its construction, its working, along with its advantages, disadvantages and applications. Today we are going to study one more type of multi-stage amplifier, and that is known as transformer coupled amplifier. As we have studied that depends upon coupling component used only, the multi-stage amplifiers are classified, out of which we studied two. One is a DC coupled amplifier and second one is RC coupled amplifier. In DC coupled amplifier, no coupling component is used, but in TC coupled amplifier, in RC coupled amplifier, resistance and capacitors are used as a coupling component. But as far as transformer coupled amplifier is there, the coupling component is the transformer. Friends, this transformer has got a particular speciality, and that is its number of turns of primary and number of turns of secondary are equal. That's why this transformer is called as an impedance matching transformer. And that impedance matching transformer is used to couple here the output of first stage to the input of second stage. If suppose impedance is not perfectly matched, then either more voltage is coupled to the second stage or less voltage is coupled to the second stage. Then that of it is amplified by the first stage. And that's why the transformer connected here is of having the equal number of turns of primary and equal number of turns of secondary, because turn ratio gives the ratio of output voltages. Means output voltage of secondary upon input voltage of primary is same as that of N2 upon N1, means number of turns of secondary and number of turns of primary. This turn ratio decides how much amount of output voltage is to be developed across that particular transformer. And this will also affect the frequency response curve of the transformer coupled amplifier, because this behaves like an inductor as a load on the first stage of amplifier wherever you are connected. And when there is a formulation of inductance, number of windings are there. In between two windings, there is a formulation of intercapacitor. And this intercapacitance and inductance may going to act as a LC circuit here. And that's why whenever the frequency of the input signal becomes equal to the frequency so-called virtually generated by means of an LC formulated by means of a transformer, maybe there is a sudden rise in output voltage, it is possible. This is the effect which is going to be generated by using the transformer to couple the output of first stage as the input of second stage. But whenever impedance matching is perfectly required, under that particular condition, the transformer coupled amplifier is widely used. Especially to design the power amplifiers, the transformer coupling concept is being widely accepted. Such a transformer coupled amplifier is represented in this particular diagram. Friends, You may consider DC coupled amplifier, you may consider RC coupled amplifier, you may consider the transformer coupled amplifier. Only what change we are going to observing is in the coupling component. In DC coupled amplifier, this coupling component is absent. In RC coupled amplifier, R and C is present to couple the output of first stage as an input to the second stage. In transformer coupled amplifier, R and C are replaced by means of an transformer. That is the difference. Otherwise, almost all the circuit diagrams are same, even though by including their biasing components. In this case, the primary winding of transformer is going to act as a load connected between collector of transistor and that of power supply, B.Sc. Whereas secondary output is given to the base of transistor 2, which is the output voltage of first stage and can be going to act as an input voltage to the second stage. Friends, such a transformer coupled amplifier, as usual other amplifiers, it also consists of a transistor, say Q1. Again, it is used in common emitter configuration, whose biasing is adjusted by means of an R1 and R2, known as resistor divider biasing aspect, by using which its operating point is adjusted in the active region so that it is going to act as a very faithful amplifier. Here emitter resistance Re is also going to provide the self biasing to the transistor, which already studied in the methods of biasing the BCD. Here Ce is going to act as the emitter bypass capacitor. The input signal is coupled to the base of transistor to be amplified via coupling capacitor, so Ci, Cc, Cin, whatever it may be. It couples input signal to the base of transistor Q1. The transformer whose primary is connected to the collector and that of VCC, it is going to act as a load on the transistor. Secondary winding are connected to the base of transistor. This will does the job of connecting output voltage as an input to the second stage of amplifier. The second stage is quite similar to that of first stage. This consists of well matched transistors, say transistor Q2. Here also its biasing is adjusted by means of an R1 and R2 voltage divider arrangement. Its role is to adjust the operating point of BCD in the active region so that it is again going to act as a very faithful amplifier. Here Re connected to the emitter again going to act as a self, provides the self biasing. C is bypass capacitor. Here also another transformer T2 whose primary is connected to the collector of Q2 and that of VCC, whereas across its secondary we can obtain the output. Here this transformer couples the output of second stage, obviously it is amplified voltage, to the measuring device. This is what the construction of transformer coupled amplifier means. When input signal is applied for the purpose of amplification with respect to as it changes in positive and negative cycles, accordingly current IB will increases. This increase in IB increases IC that will flow through the primary winding of transformer. It will develop voltage in the primary winding which is mutually linked with the secondary. This mutually linked voltage is going to act as the input voltage to the base of transistor T2. This will increase its base current, which will increase its collector current. That increased collector current passes through the primary winding of transformer T2 to generate voltage across secondary winding due to mutually flux linkage and that produces the amplified output voltage. If suppose AV1 be the gain of first stage, whose input voltage is say Vi, that develops the output voltage across the secondary winding, say VO1. Therefore, that gain is given as AV1 is equal to VO1 upon Vi. Similarly, if we consider VO2 be the gain of second stage, that will develop the output voltage VO and input voltage as a VO1. Therefore, that gain is given as VO2 is equal to VO upon VO1. Therefore, net voltage gain is AV is equal to AV1 into AV2. So that is VO1 upon Vi into VO upon V1, VO1. VO1 will cancel and the final gain will be VO upon Vi. This is how the transformer coupled amplifier is used as an amplifier. Friends, let us plot its frequency response curve. By the definition of the frequency response, we can say it is the graph of gain of the amplifier versus the frequency of the input signal. By the definition, keep input signal voltage Vi constant, vary input frequency and note down the output voltage. Then calculate the gain of transformer coupled amplifier, that is a VO upon Vi, for the different input frequencies and plot the graph of voltage gain versus frequency, which is represented in this particular figure. It is a graph of voltage gain versus frequency to be treated as the frequency response of transformer coupled amplifier. From this graph, what we can observe? From the graph, we can say that when frequency is 0, voltage gain is 0. As frequency increases, voltage gain also increases. Up to here. And as we have studied in RC coupled amplifier, that the frequency region where increase in frequency increases the voltage gain, it is known as low frequency region of the amplifier. After that, even though frequency is increased, gain remains constant. Gain remains constant. This region we can call it as it is a mid frequency region. But in mid frequency region, at a particular frequency, in frequency is further increased, at a particular frequency, the resonating frequency suddenly rises. As frequency increases, voltage gain suddenly increases. This is the region. Suddenly increases and after that it goes on decreases. So this is the particular frequency at which the resonance that takes place. So at this particular frequency, the inductance of primary winding of the transformer and interwinding capacitor which is formulated, its frequency f is equal to 1 upon twice pi root LC. When that frequency becomes equal to the input frequency, then in the circuitry, the resonance that takes place, and that's why we are going to obtain here the resonating frequency. After that, again the input frequency becomes more than that of the frequency formulated by the LC component, and that's why again the gain starts decreasing. So this is the speciality of the transformer coupled amplifier variation. So why this happens? At low frequency, a reactance of the transformer winding decreases to reduce the gain. Here the reactance of low frequency reactance of transformer is less. Hence the gain is less. At high frequency, the leakage inductance and distributed capacitor, as already explained in this particular region, reduces the gain in high frequency. So here is also gain less, here is also gain less. The peak gain is due to resonance of the inductance and capacitor. This frequency is resonance frequency. This is what you can call it as the resonance frequency. It has a small mid frequency region. Mid frequency region is somewhat less. So this is the effect of transformer on the frequency response curve of transformer coupled amplifier. Here also get the maximum gain, multiply this frequency by 0.707 as we have did in the RC coupled amplifier. You will get a particular point down the gain axis, or draw a line parallel to frequency axis. You will get again 2 points. Draw a perpendicular. You will get the upper cutoff frequency, lower cutoff frequency. Take the difference between those two particular frequency, and the result will be, one can obtain its bandwidth. So that is also well agreed with the frequency response for, as usual, any type of amplifiers. Friends, this transformer coupled amplifier also has some advantages. That is, no loss in signal power. It has a high voltage gain. It has a perfect impedance matching. Disadvantage, here we are connecting the transformer. It is a bulky, hence its weight increases and the circuit becomes expensive. If we are using it for radio frequency, then reverse distortion may be going to produced. And if we are using it in a power amplifier circuitry, especially in audio circuitry, it may going to generate hum in the circuit. So these are the disadvantages. Whereas applications, it is used in the last stage of amplification where impedance matching is necessary. That's all about third type of multi-stage amplifier known as transformer coupled amplifier. Thus, in all these three amplifiers, we studied that by cascading one stage with the other stage of amplifier, one can increase the gain of amplifier, and that is the purpose of designing the multi-stage amplifier. Friends, that's all about the multi-stage amplifiers. Next time we will go for the power amplifier circuitries.